Hi, hello, welcome to another math lesson. We're going to talk about sums and products of real numbers. Alright, so during this lesson, you're going to learn how to explain why sums and products of rational numbers are rational, explain why sums and products of rational are, and an irrational number are irrational, explain why the products of a non-zero rational number and an irrational number are irrational. Here we go. Okay, so here's our number classification chart. Remember, these things are like Russian dolls. If I have a natural or counting number, it's also a whole number, right? So natural or counting numbers are positive whole numbers. 1, 2, 3, 4, 7, 15, 100, all those types of things. Whole numbers, the only addition is we add 0. So a whole number is, so 0 is a whole number, but it is not a natural number. Integers are whole negative numbers is what we add into there. So natural numbers are also whole numbers, which are also integers. Rational numbers are anything that I can write as a fraction. Irrational numbers are anything that I cannot, like pi, square root of 3, square root of 2. And all of these things make up real numbers. So natural numbers, any positive whole numbers. We've already talked about this. 1, 2, 3, 4, 97, anything like that. Okay, whole numbers, any non-negative integer. The big addition is we add 0. An integer is any number that is not a fraction, so we add the negative numbers here. Rational numbers, this is when numbers can be written as a fraction, so we add like the 1/2, 2/3, all those in between parts. Irrational, any number that has a decimal that never ends and has no pattern. These cannot be written as a fraction. Okay, so adding and multiplying numbers. So will the following result in a rational number or an irrational? So remember, rational is fraction. This one is no fraction. So if I add two rational numbers, 1/2 plus 3/4, this will stay rational. If I multiply two rational numbers, this will also stay rational. 3/4 times 2/3, we still get a rational number. Adding a rational number with an irrational, this is irrational. Once I combine, so say I say like pi plus 5, that's still like 8.1415, blah, 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 whatever all the pi decimals are, right? So it stays irrational. The same logic applies for this next one. To multiply a rational number with an irrational, it is also irrational for the same logic. That looks horrible. I apologize. That's a little bit better. Okay. So when we add two rational numbers, 2.326, blah, 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 I still get a rational number, right? The sum of two rationals will stay rational. Multiplying, same logic, right? They will stay rational. And then adding the rational with the irrational, my decimals here, my continuing decimals are the things that get me. Okay, that's the one that changes. These will stay irrational, as well as multiplying, right? If I say pi multiplied by 4, I will get 12 point blah 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 blah. Those decimals keep going and never ends. So this one's it's a pretty quick video. If you have any questions about this, please come talk to me, and I'd be happy to help you. Most of this stuff is all basic logic. Just think about how those decimals will line up, where they'll continue. Remember, the big difference is rational numbers can be a fraction, so our decimal will end, has ending point, where an irrational the decimal will not end. Okay, so that's the big difference. If you have any questions, please come talk to me. Have a great day. We'll talk to you later. Peace out.